satellites, but only still images. So someone later reconstructed this so you can see what satellites were at the time compared, for example, to the satellite pictures that I showed earlier and that I'll show later. But they could see there was a storm coming. This shows communication at the time. This is someone standing in front of a radio where they're talking about the storm, a radio announcer, and they did have television. They even had color television where you can see someone on the storm, a broadcaster, talking with the emergency manager, telling people to evacuate in front of this big just paper map to communicate the weather forecast with people. So this shows how things had advanced from 1900, some of the same mechanisms of communication and observation, as well as some new mechanisms. And the forecast had improved, but not as much as we've seen today. Okay, so if we fast forward today, how has hurricane forecasting and communication changed? And if you just contrast that satellite image I showed you earlier with this satellite image, which is from 2017 with 3 storms, it's pretty phenomenal what we can do today. Between the satellite observations, if you think about the ways we can communicate, we can see these things on television, we can see them on the internet, we can look at them on our phones, all of those kinds of things. We can send pictures to each other. All those kinds of things are really an amazing advance. So I'm going to talk about what hurricane forecasting looks like today, and I'm going to use this example of Hurricane Irma from 2017 to illustrate that. This image from 2017 was actually at a time when there were 3 major storms in the Atlantic, as you can see, and then this is Hurricane Irma, which is approaching Florida. So in 2017 for Hurricane Irma, this is an example of one of the forecasts that was provided. This is the National Weather Service's kind of one of their flagship products that people use. This is their version of the graphic where it shows what's called the track cone. You can see in this graphic that this X here shows where the storm currently is, and this yellow kind of blob around it shows the extent of the wind speeds, and then this black line shows the most likely track. The symbols along the line show how strong the storm is expected to be at different times, and then this white kind of cone around it shows kind of some of the possible tracks, although this is only 2/3 of the time the track can be expected to go inside this cone, so sometimes it will go outside of it. And then these red and other colors show the areas where there are warnings and watches indicating that people should be aware of impending dangerous conditions. So this is the National Weather Service example of this, and a lot of people in the media, a lot of media broadcasters show their own examples of this kind of iconic forecast. And if any of you have followed Hurricane Ian, which happened recently, one of the big issues talked about during the storm was that the cone was moving around a little bit. As I'll talk about in a minute, forecasts do have some uncertainty, and so people were thinking about whether they were in or outside of the cone as a measure of whether they were at risk. And because the storm, as you can see, this wind field, even no matter where the track goes, there can be hazards outside the cone, much less taking into account the fact that the track can change. So there is risk outside this cone. So that's some of the work that people are doing, is try to communicate this forecast better. But I'm just going to use this as an example to show kind of an overview of the storm, as is often done. So this shows that same plot, and if you look a day later, you can see the storm has gotten closer. This is shortly before landfall. The storm gets bigger as it approaches landfall, and then the cone extends further north because the storm has moved further north. And if you go backward in time, you can see that I'll go backward in time one day at a time with the forecast, and you can see that at this time the storm was forecasted to affect West Florida. And then if you look further back, you can see, okay, the track is still over Florida, but not exactly the same spot. And then as you go further back in time, you can see this is about 3 or 4 days in advance. The forecast was for the Miami area, which raised a lot of concern, so there were evacuations all across Florida because of this. This was actually a very accurate forecast given the state of meteorology, but when you're talking about these areas where there's so much population, even a small change in where the storm can go can make a big difference in who will experience damage. And then you go further back in time. This was actually a very long-lived storm. It caused major devastation in the Caribbean as well. But you can see that there was many days of a track forecasting the storm to come towards Florida. So this just shows a few things. One is how much further in advance we can create forecasts these days that are accurate and can say when something is coming. although we still can't say exactly where it's going to go, as well as how much more frequently the forecasts are updated. So I've just showed examples once per day, but the forecasts are updated much more frequently than that. So there's just a huge prevalence of information today that wasn't available, obviously in 1969, but also even if you think back to the 1980s or 1990s, the information is much better. This shows some other examples of the information that is out there. This shows how the different kinds of ways that information is being communicated on television and the internet. So this shows another example of the cone, and this is from the Weather Channel, and they've sort of annotated different places where there's probable, and then U.S. impacts are still uncertain at this time. This is pretty early on in the storm. This is another example showing areas under watches and warnings as well as the possible tracks. So just the wide array of communication, and there's hundreds of these different types of graphics available at any given time from all the different TV stations and internet outlets and so on. Here's some other examples of communication. So as I mentioned earlier, it's not just about where does the storm go, but also what hazards will it produce. So this is an example on the left here of the probability of tropical storm force winds, which are strong winds that can cause damage. This plot actually looks kind of weird because there's another storm right behind it that might cause damaging winds, or is expected to cause damaging winds. So, but this is one sort of piece of communication that people are focusing on to try to communicate the wind hazard so that you know if you should board up your home, or if you live in a housing that isn't very sturdy, could it be affected by wind, as well as storm surge flooding. So this is an example of a map produced by the National Weather Service to indicate where is at risk from storm surge flooding along the coast. I'll talk about this in a little bit more in a minute, but storm surge is where the winds of the hurricane push water from the ocean to land, and it comes in very fast and has a lot of force and can inundate land and wash away houses. It's what caused so much damage in the Galveston hurricane, as well as if you watched Hurricane Ian. Many of the deaths there were caused by storm surge washing people away and their housing away. And then, of course, today, people get information from so many different kinds of ways. So there are some people who aren't on the internet and getting information all the time, but a lot of people nowadays are on their phone, on their computer, talking to people, watching TV, potentially getting information on their tablet at the same time, getting information from lots of different sources at the same time. And so if you just think about how that's different from even 10 years ago, much less 20 or 30 years ago, how you get information, it's really phenomenal to think about how this has changed the ability to communicate and the kinds of information we can get and the complexity of the information. So that's some of the work that we do now, is to think about that and think about how can we communicate better given all the different ways that people can get the information and the improved weather forecasts, but also keeping in mind that people might not be online at any given point, or people might be getting information in different ways. There are people who might not speak English, for example, and still be watching TV in a different language. And so how do we communicate with the real diversity of population that's out there and make sure that as many people as possible are aware of what can happen and protect themselves. So now I'll talk briefly about how modern weather forecasting works. Of course, this is very simplified, but it's a lot of work that NCAR does and a lot of researchers at universities and with the National Weather Service and other groups. So I talked with the Galveston hurricane and with Camille about the observations that were available at that time, and today we have a much more complicated global observing system. We have many satellites that produce very high resolution data. We have weather balloons that I think are still in here somewhere. Yeah, here's the weather balloon. We have radars, we have ships, there's airplanes. There's airplanes that fly out into storms still when there's a storm in order to take data to improve the weather forecast. Oops. And so there are all of these observations that really provide the basis for the forecasting. And how modern weather forecasting works is you take all those observations and you put them together and then you run them in a computer model. So this shows an example on the right of what a weather model grid might look like. So you have a computer model that has a grid that has different points all across the globe, and then it uses really complicated equations like this with a computer to move them forward in time and predict what's going to happen. And there's also this very important piece called data assimilation, which is how you combine the observations with everything else to start off the weather model. So this is all the technology behind it. Of course, it requires data, it requires computers, it requires people to know how to do all of these things, and it's very complicated. So it's really observations, computer modeling, and humans, and lots of other things. But this is just an idea of how modern weather forecasting works. And then what usually happens is that weather model produces output, and then forecasters, human forecasters, and computers look at it and interpret that in terms of weather that people might care about and decide how to communicate it. So advances in science and technology have really yielded these improved weather forecasts. I talked about the observations and the models before. Of course, there's supercomputers behind all this, and as supercomputers get faster and faster, that advances the capabilities. And then this enabled a lot of scientific knowledge. So the understanding that we have about the weather has really enabled people to interpret the weather models, be able to use their knowledge to improve the weather modeling and how it works, and how the observations are put into the models, and so on. So all of this together really has yielded these huge advances in weather forecasts that I talked about earlier, and that I showed with these examples from 1900 to 1969 to today. So today's weather forecasts are more accurate, they're more skillful, people like to make fun of weather forecasts because they're all often wrong. They are usually wrong in some way, but they're a lot better than they used to be. I'll talk about why that is in a minute, why they're often wrong in some way. They're more detailed, so they can provide a lot more specifics about what's going to happen. They're available much further in advance, as I showed with that example from Hurricane Irma. To be able to say a storm is approaching Florida 7 or more days in advance is just tremendous. And they also better represent the confidence or uncertainty in the forecast. So as I'll talk about in a minute, weather forecasts are inherently uncertain, but really being able to estimate when they're more accurate, what the uncertainties look like, has really also been a huge advance, and they're continuously improving. If I were to give this talk in 5 years, actually probably even next hurricane season, I would be able to show you some advances that were made based on the research and technology and so on. Okay, so now I'm going to talk briefly about why there's uncertainty in weather forecasts, both because it's really important and it's one of my favorite topics. It's what my PhD dissertation was on, but also because it's really important for what I'm going to talk about next in communicating. So just briefly, some of you might have heard of chaos theory. One of the founders of chaos theory is Ed Lorenz, who is a meteorologist. And he wasn't trying to find chaos theory, he was just trying to predict the weather and kind of ran into it along the way. But one of the reasons why, one of the kind of themes of chaos theory is that this plot here shows a Lorenz attractor, and if you have initial conditions that are close to each other like this, so you have the real atmosphere, you can think of the real atmosphere as one of these dots, and then a weather model is another one, and another weather model is another one of them. So each of those weather models doesn't represent everything in the atmosphere, but it's pretty darn close. And if you move those forward in time, in real time, the real atmosphere, or in model time, you can see that they get further apart until eventually they're not close together at all. And so this is one of the reasons why weather forecasts are uncertain. There's a lot more complexity behind it, but this is one of the reasons. Just a side note is that when people talk about this, they often say, oh, well, how can you predict climate then? And there's a whole different thing that goes into climate change. There's other things that are influencing the ability to forecast climate. But this shows why weather forecasts are not perfect because of this inherent uncertainty, which is really unavoidable in weather forecasting, and this is one of the reasons. So how this kind of plays out in actual hurricane forecasts, some of you may have seen maps like this on TV. They're called ensemble forecasts, or they call them spaghetti model plots because they look like spaghetti. So this example shows, this is for Hurricane Irma. Again, the forecast was started when Hurricane Irma was right here, so the hurricane had already come this way. And then these are different model simulations, different computer model simulations of the storm going forward. And as you can see, initially they're pretty close together, but then those small differences in their initial conditions, and the other aspects of the model, they diverge over time, so that as you go forward, you can see that by the time you get to US landfall, they're really affecting very different areas of the coast. So this is, I think, more than a week in advance of the storm, or about a week in advance. And then as you go forward in time, so this is a simulation that started later, or a set of simulations, and these are all the different models, and you can see that they're initially close, and then by the time they hit Florida, because it's closer to the storm, they're not as far apart from each other. And then as the storm gets closer, they don't diverge as much. They tend to kind of reduce the uncertainty as you get closer to the event. So this is to kind of illustrate that this uncertainty in weather forecasts, or lack of perfect prediction is kind of inherent. There's no way to avoid it, but we can estimate the uncertainty, and then as the event gets closer, usually your uncertainty can reduce. You can predict better what's going to happen. And then if you think about things advancing over time, what I showed earlier is that this used to be, say, what a 2-day forecast was, and now, 10 years later, it's what a 3-day forecast looked like. So your skill does improve over time as well. Okay, so another important thing is that hurricanes are more than wind. So it causes different hazards. When a hurricane is approaching, people often think of it in terms of strong winds and flying debris. Also very important is coastal flooding from storm surge, inland flooding from heavy rain, depending on the storm. They can cause different things, or both can combine, as well as tornadoes. And so this example, this shows storm surge. On the bottom right, you can see a simulation of coastal flooding from storm surge. You see the water coming in from the coast and inundating the buildings. This shows a schematic of how the water comes from the ocean and gets blown over land. And so storm surge is a major risk, as I'll show in a minute. Of course, hurricanes can also cause major disruption to power, transportation, communication, other critical infrastructure. People can have difficulty getting food, water, hygiene, all those kinds of things, medicine that can be very important. So hurricanes can have all of these different kinds of impacts. If you look at the major causes of loss of life from U.S. tropical cyclones, this analysis is from about 10 years ago, and so it gets updated over time. So the details change depending on the storm, but the big picture doesn't. That if you look at the direct deaths, about half of them are from storm surge, or a large number are from storm surge. And the reason why this is the case, as we saw recently with Hurricane Ian, is that storm surge isn't major in a lot of storms, and so it doesn't cause deaths in every storm, but when it does cause deaths, it can often cause a lot of them. And so Hurricane Katrina is one example, Hurricane Ian is another example. Rain actually causes a number of deaths, heavy rain that leads to local flooding, which can happen far away from the eye of the storm. That was actually another major factor in Hurricane Ian. Some of the deaths were inland from rain flooding, and then other kinds of hazards do also cause deaths. There's also a number of indirect deaths, so deaths that are attributed to the storm, but are not direct in that, water or wind from the storm killed someone. There's heart attacks from the storm. There's people evacuating, getting in car crashes, or something else happens. There's people losing power, getting electrocuted, trying to clean up, getting damaged by a tree afterwards, all those kinds of things. So there's a lot of indirect deaths as well. But so this is just to provide some context about the kind of harm that can happen from hurricanes and why, what kind of harm we're trying to reduce. Okay, so now I'll talk about how can you reduce hurricane impacts through interdisciplinary research. This diagram on the bottom shows this classic hazard and disaster warning cycle where people prepare before a storm and there's warnings and they can respond, and then there's a long-term recovery process as well as longer-term mitigation. And this event is what causes the impact. So the hazardous event combines with kind of where people are and what their built environment looks like and their vulnerabilities to cause the impacts, which are deaths, damage, disruption, everything else that when you see hazardous weather on the news, kind of that's what's happening. And in order to reduce those impacts, people can take different kinds of protective actions. So a classic example is evacuation. They can move someplace safer that's less at risk. For things like flooding, sometimes you might not drive your car because flooding on roads is a common cause of death in flooding. There are other things you can do, like protect your home, prepare for a power outage, gather supplies, all those kinds of things you can do to reduce the hazard impacts. And I've talked a lot about the hurricane forecasts and the warning information, which I'll talk about as different kinds of risk information. And that information is what lets people know that they should make these protective decisions. So if you think about a hurricane coming, if you didn't have a forecast, you wouldn't know it was coming, and so you wouldn't know to do anything. So in the weather forecasting world, this advanced information is really important. So we think about this information, people getting it, taking actions that can reduce impacts. But there's a major complicating factor in the middle, which is that the information doesn't go straight into decisions. People have to get the information. It's communicated in all the variety of ways I talked about, and they have to interpret the information. It intersects with their beliefs, what they think can happen, all those different kinds of things, their capabilities. Do they have a car to evacuate? What kind of structure are they in? Is their family at home? All those kinds of things. Does their grandmother want to evacuate? All of those kinds of things. Do they have a job that they need to stay at, and so on, all intersect to intervene between the information and the decisions. And so a lot of the work that we do is really trying to tie all these pieces together, understanding the forecasts, the uncertainty in them, the capabilities, how the forecast can improve in the future, and then the actions that we think can help people protect themselves, and kind of in this space, understanding what's going on and how we can improve the situation. So a lot of what we do is really work backwards from these decisions through the interpretations and the communication, to really go from what people are thinking when they get the information, what they can do to try to improve the information that the forecasters and the weather community is producing, and tie all the pieces together. So I'll just talk briefly about some of the ways that we do this research, the methods that we use for understanding what's going on in this complicated space. One is surveys. We do a lot of survey work where we ask people different kinds of questions, and then analyze the data using statistical analysis to understand what they're thinking and how things are interacting. We conduct interviews where we walk people through different situations or ask them about what happened during an event to understand what's going on. We do focus groups. This is an example of some focus groups conducted by my colleagues that I'll talk about later, where they were showing some maps and asking different people how they would use that information. We use experimental changes in messages. So this is an example from a study where we tested changing something on the National Weather Service page in a hypothetical setting and asking people how they would respond to it. So we use that to kind of test what could happen in the real world. And then we also do computational modeling. This is an example from some work where we, with some colleagues, built a model of an approaching hurricane and the forecast, and these little dots show different people making decisions and deciding to evacuate. So with this kind of thing, of course it's not a perfect model, but you can simulate situations you can't simulate in the real world. You can say, okay, what if Hurricane Irma did this, or what if people acted in this way? So these are some of the kinds of tools we use. We also use analysis of social media data, including Twitter. And this is something we've been doing for the last 10 years or so, because Twitter data is analyzable for research. So this example just shows how during the 2017 hurricane season, you could see the number of tweets about hurricanes change with the storms as they made landfall. And then we can really dig into this data deeply to understand what kind of information is being communicated, how people are responding to it, how they're sharing it, all that kind of stuff. So this just shows one example from a tweet here from someone who was providing weather forecast information. He tweeted about weather forecasting as Irma was approaching landfall, and then someone replies and says, can you tell me what I need to do? Do I need to get out? Okay, so I've talked about how advances in science and technology have really made huge advances in providing more accurate and more detailed weather forecasts further in advance. I've also talked about how advances in interdisciplinary research have improved weather risk communication to support risk interpretations and decisions. And all of these things are still ongoing. There's a lot of people working to improve the forecasts, as well as now in the weather community really working to improve the communication and to understand how people are making decisions. So next I'll talk about really one of the possible solutions to this that the weather community has been working on for the last 10 or more years, is really how to improve forecasts of hazardous conditions and impacts given the predictive uncertainties. So I talked about how weather forecasts are unavoidably uncertain, so you can't say 20 days in advance a tornado might hit this location. But given those uncertainties and what we know about them, how can we improve forecasting the kinds of things that people care about that are going to affect their lives? So next I'll talk about that a little bit. For this, I'll use an example from some research I did about 15 years ago after Hurricane Ike, which was a major storm that affected the Galveston area, the same area that was affected by that 1900 storm, where a colleague and I went down after the storm and did interviews. It was a pretty amazing experience to talk to people who had lost everything in the storm and what they knew before the storm, what they were thinking, all those kinds of things. That has really informed my research. So Hurricane Ike was a large Category 2 storm There was a 20-foot storm surge predicted for the Galveston area, so it wasn't the strongest type of storm, not a Category 4 or 5 storm, but it was strong enough to cause wind damage. And then because it was such a large storm and where it was expected to affect the coast, it was anticipated to produce a large storm surge. As I mentioned, there had been a seawall built in Galveston. You can actually see the edge of the seawall right here. It turned out, and the seawall is 17 or 18 feet high, so there was a lot of concern that the water was going to go over the seawall. It turned out that the worst storm surge was a little bit further east, so the water didn't go over the seawall. It just went around the back side of the island and flooded the island from the back. So you can see what the kind of damage storm surge can do. This is on the ocean side of the seawall, and this is what the damage looked like in Galveston. This is actually a few blocks inland. If you're right along the coast, the storm surge just like tears a giant hole in the middle of your house. And then inland, people, you can see this is their lives are everywhere. Their homes were destroyed. So we asked people, we did interviews and asked a number of questions, but what I'll focus on here is that people were getting a lot of information before the storm, even back, in the old 2008 days before we had mobile phones and I guess social media. I don't know what we had back then, but they were watching television, they were using their computer every once in a while, stuff like that. They were getting a lot of information, they told us. And a lot of them really believed their property might be at risk, and most of them did something to prepare their property. But only about a quarter of them prepared for flooding, and these were all in flooded areas we were doing these interviews. And it's because many of them never expected flooding to be so bad. And so you can think back to the Galveston storm and what I said then, that people said they didn't expect flooding to be so bad. Again, Hurricane Ike, they didn't expect flooding to be so bad. And people told us a variety of reasons for this. Some reasons were because of the mitigation. Some reasons were because of the forecast. They evacuated before the forecast of the major flooding, came out, because it's hard to predict flooding so far in advance. But it's really sad to talk to people afterwards and have them say they only wish they had known. And that really motivated a lot of my work in this area going forward, to try to see how can we improve communication and help people understand what they can do so that they can even just save their picture albums or their most precious things, even if they can't save their home. So this is an example of a quote from one of those interviews. Someone said, "I never dreamed of 7 feet of water in my home." People might have moved things, but they moved them up to a shelf a little bit higher on the bookshelf, but that was flooded as well. And these are some examples from some of our other studies. One of the focus groups we did after a hurricane, someone said, we knew about the risk, but by the way it came in this time, it was just mind-boggling. They just couldn't believe that this could possibly happen. And then on one of our surveys, we asked people what information they would want, and they say they would want more specific information and really local information. Like even the information they got wasn't local enough. And this is an example from one of the Twitter studies we did, where a forecaster says storm surge may reach 8 feet with waves on top, Rockaway set for major flooding, and this person tweets right back, they live right in this area, and they say, define major flooding, please. So the forecaster thinks they're defining major flooding, but this person wants to know what's going to happen to me. So really, we find throughout our research, and others have found, that people want to know what hazardous conditions and impacts they will experience, and then the question is, how can we communicate this given the limits of predictive skill? And that's really a major challenge for weather forecasting that people are working on today. So one possible solution, as I mentioned, is forecasting and communicating hazards and impacts. And so on the left here, this is an example from one of our studies where this is sort of a standard map of what, keep going forward by accident. Standard map of what a storm surge map looks like. And so this is one way that we tested communicating, showing people that what the flooding looked like compared to a house. And for some people, this was really helpful. They said, oh, I can see my garage is going to be underwater, my fridge is going to be underwater. For other people, it didn't help as much because they said that my home doesn't look like this, I don't live in this kind of area. So it shows the opportunities and the challenges. This example here, this is a video that's going to play that shows storm surge inundating an area. So this is based on some past work where people said they really didn't know how fast it could happen. They thought they'd have time to gather things. And so this was designed to show how fast storm surge can happen. This simulation is a sped up version of 12 minutes, which you can see on the bottom. And for example, one of the people that saw this said, the map coupled with the video would really help because you can see how fast it's going to happen, and that you really do need to get out because you won't have time to run or to get in your car and drive. So again, I've talked about the advances in science and technology and improved forecasts, all the interdisciplinary research we can do to improve the communication, and then the importance of improving forecast and communication of the things that people are going to experience so they can really personalize it and understand what they need to do, what can happen, and what they need to do. And the last thing I'll talk about briefly is really kind of where we're going next, which is forecasting and communicating in ways that really connect with people's capacities. So really thinking about all of these things together and doing this in the complexity of the modern information environment, which is all the complex ways that many people are getting information today, and the really complicated information that's out there. It's not like back in the Galveston or the Camille days where there was one or two pieces of information. Now there's hundreds and thousands out there at any given time. So as I mentioned, with this kind of simplified model of, we think about hurricane information, people interpreting it, and the actions they take, really what we see in our research is these things are all intermingled today because people are getting information all the time. They're talking to their neighbors as they were in Galveston, but their neighbors are on the internet getting new information, asking someone, questions on social media and all those kinds of things. So all of this is really happening in a complicated way. And so this is just one example from some of the work we've done with Twitter or social media as a way of understanding what people are doing during a storm. So you can go back and interview people after a storm, like I've talked about before, or survey them, but it's really difficult to understand what they were thinking at the time and kind of understand, given this information, what did you think? Given this, at this time when this information was available, what did you think? And these are ways that we can kind of go back and try to reconstruct what they were thinking and doing at different times so we can understand more specifically where the gaps are that we can try to improve communication. So these are just some examples of the kind of information people talk about getting. They talk about evacuation orders for a hurricane, when the storm's going to come. They talk about hearing what other people are doing. They talk about what they can smell and see and hear. That's a lot of how a lot of people experience weather. They use their environment around them. We get a lot of information about their interpretations. This is just one example. This is someone who said, my block never floods, so I'm mostly worried about things coming through a window or wind. There's also a joke, so people make a lot of jokes during storms. This is another example of a joke that someone makes. People actually, tell us that they eat a lot during storms and they watch movies, but actually if you look at the research on risk communication and decision making, this is a way that people cope with their fear. So when they're afraid about something happening, they do things that are gonna help themselves feel better or pass the time. And then of course people do things like they pack their things and evacuate. So these are the kinds of things we're looking at to understand what different people are doing and kind of, if someone's really in a high risk area, what can make them switch over from baking cookies to saying, I need to pack now, those kinds of things. So I just talked about how these responses, interpretations, perceptions, and so on, and information is all interlinked. And so if you think about this as a person, and each of these people is evolving over time, so we're trying to observe what they're doing at different times to understand their trajectory as a weather forecast, a weather event approaches, and see how they're responding to different kinds of information to identify places where if we could have given different information, that would have helped. And then, of course, all these different people are interacting. So just as a last point, one of the areas we've been working in the last few years, and one of the areas that we're trying to go, and we'll see if it's possible, but really is to take methods that we have, such as analyzing social media data or data available on the internet, or doing surveys in real time, to ask people in real time as a weather event is threatening, what are they thinking? What information are they getting? What do they think is going to happen? So we can identify if there are misunderstandings that we could then, and weather forecasters can then intervene and try. Oh my gosh, sorry, I didn't mean to do that. That was my phone. Weather forecasters can intervene and try to improve the communication. So that's something that we're hoping maybe in the next 10 years that may develop. Is the real, right now what happens is if you're a meteorologist, you watch an event happening and you see this person thinking that, or you ask someone and they tell you what they're thinking, but we don't have really kind of data across a large enough population to really be able to say, oh yes, this one thing is really widely misunderstood in this area, but these people are understanding this. And so really to try to improve the communication by, just like we take planes out and have satellites and so on to observe a storm in real time, can we observe what people are thinking and doing in real time and how they're interpreting the information so that we can improve it? So I'll just close by reviewing what I've talked about. Again, weather forecasts have gotten so much better. If you haven't gotten that point, I hope you do. They really have gotten a lot better. There's a lot of advances in interdisciplinary research and bringing different fields together to improve weather risk communication. It's really important to not only improve forecasting a weather phenomenon like a hurricane, but also what is going to happen in different areas so people can make better decisions, of course, given the uncertainties I talked about, and then really to forecast and communicate in ways that connect with people's capacities and collaborate to really not be communicating to communities at risk, but really communicating with them about what they care about the most and what information they can use given their situations to improve their forecasts. And really to meet people where they are, instead of saying, we're the forecasters, we're the scientists, we're communicating with you, to really meet people where they are, the things that they can do, and potentially using real-time societal observations as well as meteorological observations. So I just want to close, again, with my acknowledgments, and I also wanted to close by dedicating this talk to one of my colleagues, Heather Lazarus. Heather is one of the people who conducted these focus groups that I've shown here, and this is Heather right here. And unfortunately, Heather passed away very recently after a long battle with cancer. And so it's really Heather's work. Heather's the one who really helped me understand about these capacities and this research about communicating with people and meeting people where they are. There's a lot of the work we did together. So it was a huge honor to work with Heather. She was a close colleague and friend, and she's informed a lot of the work here today, and we hope to continue working with her legacy. So I will stop there and take questions. And I think that the microphone is going to be passed around for the questions. So if you want to ask a question, you can raise your hand, and someone will bring you the microphone. And then please speak into the microphone so that the people who are listening online can hear. Thanks.
Living in the Louisville area,
Yeah.
How did you personally handle your family and your situation when you heard about the winds?
Yeah, that's a very complicated question. Yeah, so I was home that day with my children, as were many other people. I actually left when the fire was happening, and I knew it was very windy, but I did not think the fire was going to get to my house because I lived so far away in the middle of suburbia. And so because it was smoky and my mother was visiting, and she's in her 80s, we were going to go to the zoo that day, so we went there to get away from the smoke. We had planned to do that, and so then as we were driving to the zoo, my phone was dinging, and I knew that things were wrong, and then it was too late to go back. And so then the whole next few hours were people telling me what was burning, our friends and neighbors, and just that process of, like those people who I talked about in the Galveston hurricane, or in Hurricane Ike or Hurricane Ian or any of these events, like how do you understand that something you never thought was possible is happening? And I actually, because I studied this, I watched myself go through that process, like the information coming in, the text messages one of my kids was getting, the information we were getting when you start to think about this really happening, it's pretty amazing. And yeah, and then of course, so many people I know went through these experiences, and so talking to everyone else about what they did and what they thought it's unforgettable. I'll just put it that way. But I mean, it's really a challenge, I think, overall, as someone who studies this, to know that you can't go through life thinking bad things are going to happen all the time, and so sometimes people. One place gets unlucky sort of all the time. And we were actually very fortunate with some really good firefighting and a lot of good luck. Our house was not burned down, but we thought for at least 12 or 18 hours that our house was gone. And then so many people we know, their house is gone. And so it's really informed how I think about our research. And I did have compassion before for people who didn't know it was going to happen, but having experienced it, you can know a lot, but you can always make mistakes. So, yeah, that's maybe the short version. I don't know.
Hi, We were in Boulder at the time of the big flood, but we live in Pinewood now, and Pinewood had its own big flood.
Yeah.
Years before the big flood, I would go to meetings and they would talk about the little clickers they had on the streams and how that would predict if it's going to flood. I mean, they really seemed like they were on top of it. And we lived on a rise. I mean, we weren't even in like a floodplain or anything. And we ended up getting 1.5 feet of water in our basement because it rained so hard it literally pushed into the basement. When you look at the Boulder flood now, or any of the other ones that were happening, I'm sure it happened in Longmont and stuff too, was that a success or a failure? I mean, it seemed like they were really prepared, but then it was really a mess.
Yeah, that's a really good question, and unfortunately I know a lot about that one too. We had actually done a study of flash flooding in Boulder before the floods. So we had talked to meteorologists, weather forecasters, emergency managers. We'd been in the Boulder emergency manager office. They told us all about how they were prepared. So when I was watching the flood happen, I would say it's amazing success and amazing luck that there wasn't more loss of life. I mean, when I was watching what was happening, I was just picturing how many people would have died, and that's what the emergency managers were thinking too. So in that sense, and the Marshall Fire was the same thing. It was phenomenal that a lot more people could have died. Of course, some people did die, which is very sad, but it could have been much, much worse given how, I'm trying to think of how crazy things got. I think what happened in the Boulder flood was the forecasters and the emergency managers, they had thought of their scenario they were preparing for was something like the Big Thompson flood, which happened up in Fort Collins many years ago. So it was really like one canyon being flooded, and they hadn't envisioned a scenario where it flooded for 3 or 4 days, and every canyon was flooded, and they couldn't get anywhere, and they couldn't get anything in the air for several days. And so the emergency manager told us stories about people who were in these dire situations, and they couldn't do anything because they couldn't get there. So, yeah, I mean, as far as, because I've studied flooding, I know that what happens when flooding happens is that the water kind of goes where it wants to. So it goes over streets, it goes through other channels. And so it was a really extreme weather event. I think up in Longmont, I don't remember the exact details, but there was an area where they had filled an old riverbed and trying to rechannel the river, and the water just went back, to its old place and took out some houses, and people just had no preparation at all because they didn't even know they lived in a flood risk area, and it was just like all of a sudden. So I guess there's two pieces of that. One is that, that's what extreme weather does, is it's extreme. So it goes outside what we prepared for. And so, but the more advanced notice we can have, the more preparation we can have, the more the emergency managers and others can think through different scenarios, really helps them get up to speed. I think another challenge with the Boulder flood was that it happened, the flooding got really bad at night, and this is often the case, like at the Marshall Fire or tornadoes or other events, it takes time to figure out what's happening. Like when it's actually happening, they don't know where the water's going. They have people calling saying, what do I do? And they don't know where the water's going. They don't know where to send the firefighters. So all of those observations that we can get something in the air to see what's happening, or have some modeling that can say, okay, the water, we think it's going here, to kind of help you get people aware as soon as possible, so that the people whose basements haven't flooded yet, maybe you can figure out a way to tell them your basement might flood, so get the most important stuff up. So yeah, they were very prepared. I mean, they're phenomenally prepared, really. It's pretty amazing. And they were still caught by surprise. But there were ways that their preparation did really help that I'm not going to talk about now, but there are some details of how the preparation did help things, not be worse. So, yeah, I guess that's the way I think about it. It could have been a lot worse.
How much does the fragmented communication these days cause you troubles trying to communicate hazards and things like that? If you get all of your information from YouTube or things like that, how do you learn about what's out there?
Yeah, that's a great question. I mean, there are also people who don't watch local TV. They're always watching cable TV, or For example, during the fire, I have a teenager who we almost left him at home that day because he didn't want to go to the zoo, and he would have just been like plugged into his headphones, not answering the phone. Right, so there is that situation. What we do find in a lot of our research is that a lot of people that you think wouldn't get information do get information from someone. It's a matter of someone else coming to them or calling them or getting the information. And so being plugged in is what enables you, even if, for example, we have examples where someone who's an elderly Russian speaker who lives in an area that's about to be affected by a hurricane, they're watching Russian TV, listening to Russian radio, not on the internet, but their nephew who lives in California will see it and call them. And so there are ways that all that information kind of filters in, but that's about people who aren't online. But people who are just watching YouTube, hopefully someone's like Discording them or Instagramming or whatever to let them know what's happening, or they have time to do that. We worked for a while with some colleagues who study computer and information science. And when I started working with them 10 or more years ago, that's kind of how I thought about it, the way you're talking about it. But in working with them, the way they talked about it was that people are inventing new things all the time. And by the time you understand what's going on, some teenager is going to invent something, or someone's going to invent something new that's going to change everything. And so they really think of it as much as an opportunity of kind of the creativeness of how people are communicating today. And I've definitely seen examples of that, of how in my own experience with the fire or watching other kinds of events where the creativeness of how you can see an internet news story and be like, oh, that's someone I know, and go to Facebook or Twitter and be like, oh, I know this person who might know this or who lives there, or see this source of information, and how when kind of things do go crazy in these events, how different people communicating at the same time can somehow filter so that people can get the information more quickly. And there's lots of work that's been done on that, about how people can use these communication mechanisms to kind of come together in times of disaster, to protect themselves, to help each other, all those different kinds of things. So I think it's an opportunity as much as a challenge. And the other thing, it's just the way the world is. We can't change it. That's the other piece of it, is we don't control that. And so then I think our role is to use it as much as we can as an opportunity and identify the challenges and ways to address them. And I mean, in weather, we haven't seen examples yet of like evil bots trying to miscommunicate weather that we know about, but that might be coming. But that's a whole nother thing. But there are examples of kind of how in even the weather communication realm, there can be misinformation just because people see something and they think it's a tornado, or they hear this, or they're just, and how that information can be corrected. So if a lot of people are communicating, that also gives opportunity for correction as well as kind of misinformation.
So you mentioned different ways of getting that information, whether it's news, cable, or social media. But I think something I've noticed a lot more is emergency text.
Mm-hmm.
I feel a good amount of people already have phones available, and I'm curious if there's data on how effective that's been in getting the message across. Like, you may not have all the graphics, but you're like, oh, okay, I'm in the location where that's being, hazards happening.
Yeah, it is helpful, and it is one way that people get alerted. And people have studied the best ways to communicate and what's more effective. I think there's also a lot of challenges with it. If the message doesn't go out, if you're communicating over a large area, it can take a long time for the messages to get to people. I actually had an experience, I think I was driving from Longmont back to my house, and I must have passed through an area where there had been a warning. It was a police warning. And I got the message that the warning had been cleared, but not the warning, and I didn't know where it was for. So when I was driving, somehow I clipped the edge of the area where the warning was being cleared. So then it leads to, people have to seek more information, but it can be an entry point to seeking more information, which can be really valuable. I think the real challenge is those systems can get people to be alert, know something might be happening, pay more attention to their surroundings, but it can still be really challenging to decide what to do. And I have a friend who, during the Boulder floods, about 10 years ago, was driving she lived in Lafayette, into Boulder, and she got a message on her phone that was a warning, and it said, seek higher ground. And she's just driving on the plains, so she drove up to a little local hill in the dark. She's like, here I am. And then she thought, like, what do I do? I don't know. Do I sit here and wait, right? And so that can be the challenge. When there's a situation that's very rapidly changing or complicated, you still have to figure out what to do, but it was the first alert to be like, okay, seek more information. And I think if she looked outside and saw a bunch of water coming, she would have been like, oh no. So we do see plenty of examples though where, you get the warning and then you're just like, okay, well, what do I do now? But at least it alerts you to look for more information. And it can be a link to get more information. You can click on it sometimes and look and so on. Or phone a friend and ask them. It still works.
Great presentation, thank you. My question is about earlier on in your slides, you showed places and dates where hurricanes have happened. And I was curious, are the frequency and magnitude of these storms increasing as like climate change occurs or, due to some other anomaly?
Yeah. That's a great question, and I have to say I haven't kept up on the latest research on that, so I'm not the best person to answer it. But I think the research that shows that hurricanes will or are producing more rain is pretty strong in the sense that you have more heat and you have more rain. There have been more incidences of rapid intensification of hurricanes in the last 5 years, which Ian was an example of that, and there are others where a hurricane will, say, reach the Gulf of Mexico and rapidly intensify, and that's because of the ocean is warmer and that warm layer is deeper, and that's something that's a kind of first order effect of climate change, that there's more warmth and so the ocean is warmer. I think the complexities of will there be more hurricanes, will there be stronger, there's different research on that, and I don't know the latest. I think the other challenge with hurricanes is a lot of it isn't just will there be more of them, but where will they go? And so it really matters if they, hit land. But I think there are things we do know that indicate that hurricanes might be they're rapidly intensifying, for example. That makes them harder to predict. It makes them hit land, stronger. If they're producing more rain, that's more damage. And so those things, all together make things worse, as well as just sea level rise in general. So you have the same hurricane on top of an area where the sea level has risen a little bit, the water can go much further inland. So there are lots of ways we already know that the climate change is affecting the potential for damage, and then there's lots of other ways that people are still studying and trying to understand. But with extreme events, you're sort of on the kind of extreme end of the distribution of what can possibly happen, and so it can be harder to say exactly how climate change is affecting something or not, but there's a lot of people looking at that question.
I think we have time for one last question.
Regarding the different categories of hurricanes, my understanding is it's mainly focused on wind speed, but there's other factors such as storm surge and forward winds that can determine how devastating a hurricane actually is. I've heard of discussions happening with kind of changing the categories. Is that something that is happening, and is NCAR participating in those discussions in any way?
Yeah, that's a great question. I'm trying to go back to that slide. I'll get there eventually. Yeah. So, so originally the Saffir-Simpson scale, as Saffir and Simpson originally created it, actually had things besides wind. It had storm surge and other damage associated with it, and that's because they didn't have very good observations then. So they were mainly determining based on what happened afterwards. And then I think it's about 10 years ago, the National Hurricane Center decided to take out the storm surge and other damage and just make it a wind scale, because they realized that there was some miscommunication. So there have been a number of different proposals for how to improve the scale or change it or add things to it from different kinds of people, and including people at NCAR. I think the challenge is that people know what the Saffir-Simpson scale is, and they understand it in most cases. And so, actually, I have a colleague who also studies earthquake prediction, and she says that the people who do earthquake prediction really hate the Richter scale because it's a magnitude of the earthquake, but it depends on where it happens and how close to this and what the shape of the fault is. And so one number can't really communicate all those things. And so I think there's just still a lot of discussion about how do you communicate the complexity of the risk for different people, where one person might be more at risk from wind, and another from inland flooding, and another from storm surge, and another from power outages. So I don't know if that's really an answer to your question, but there have been a lot of different proposals. And no clear answers yet. There's not one that's kind of been adopted as the new thing yet, and I haven't seen something where, based on what I know, I can think, oh yeah, that would like really help. It's like, I think it seems like everything I've seen so far, it's like, yeah, that could make some things better, but it might make some other things worse. So it's still something people are working on.
Let's thank Dr. Rebecca Morss for a fabulous presentation. I'd also like to thank NCAR and the Explorer series and all of you for joining us. See you soon.
Thank you, everyone. Have a good rest of your evening.